Hello, everyone. This is Professor DePaulo. Welcome back to Psych 220 Behavioral Statistics Lab. And this time we're going to be talking about the correlated groups t-test and a little bit about bar graphs. So, correlated groups t-test is also known as paired samples t-test in SPSS. So, that's used interchangeably. Correlated groups, repeated measures, paired samples, matched samples design. These are all the same thing. So we use them interchangeably, paired samples, correlated groups, repeated measures. T-test means you have two conditions. So this is generally before and after. And that's what we're doing here. We're looking at scores before and after a GRE prep course. So GRE is the graduate record exam. It's a course that people take to get into graduate school, especially PhD level. And it's important to score high on this so people are willing to pay for a prep course. And this is what we have. We have the before score, and then we have the prep course, and then the after score. And we want to see, is the prep course effective at increasing or improving GRE scores? So we are not creating a dummy variable here. You only use the dummy variable when you have independent groups design, whether it be independent groups t-test, or you have a one-way ANOVA, where the groups are independent. In the case of correlated groups or paired samples T, we are going to just list both columns. We're going to have a before column and an after column, and we are not going to have a dummy variable column. So we're going to enter the data into two columns, which I've done. We're then going to do analyze. Now, it's very important that the data is matched up correctly. You have to enter the data in order because each row is one person. So person one scored 1050, and then they scored 1120. So you have to have them paired up precisely. They have to be in the correct order. With independent group design, it doesn't matter the order, right? With paired groups, they have to be in the correct order. They have to be matched up before and after. So analyze, compare means, and we're going to look at paired samples t-test. We're going to look at before and after in the same row, right? We don't need effect size for now. And that's it. And then hit OK. And here's our before. So before people scored 1,075. After they scored 1,117. So there was an increase around 40 something here. You see the difference here, 40 something, right? This paired sample correlation, this just shows you the correlation between before and after. This should be very high because these are the same individuals. So these scores should be correlated before and after. If this is not correlated, if this is close to zero, then there's a problem. Then you probably don't have the same people in each condition, right? You probably have different people. This should be very high when we're running paired samples t-test. So we can just ignore this. I'm just noting that it's high and it's significantly different than zero, of course. What we're looking at is this T table. This is the mean difference between the two conditions. We want our T value, negative 2.105. So it's going to be T degrees of freedom again, which is number of pairs minus 1, which is 14 here because there's 15 pairs of scores, equals negative 2.105. And in our p-value, we're looking at, we're looking at directional here because we're expecting an increase. So we're going to do one tail, p equals 0.027. It's important we're doing one tail here because the one tail is 0.027, the two tails 0.054. So if I'm looking at a non-directional hypothesis, I'm going to fail to reject the null. But if I'm looking at a directional one-tail test, I'm going to reject the null. So since I'm expecting an increase from the intervention, we are going to reject the null hypothesis. And the GRE prep course seems to be increasing GRE scores based on our sample. We reject the null. And that's how you do correlated groups. Let's take a look at another problem. Go down here, take a look at another problem. Well, actually, we're going to look at graphs first. Let's look at graphs. So there's a couple ways to look at graphs. The way I've designated on the worksheet is to group these by a dummy variable and look at the graphs that way. So we can try looking at it that way, but we can also look at the graphs side by side. So we're going to do graphs, legacy dialog. Actually, this legacy dialog is gone from here. Okay. I usually had legacy dialog in here, but I don't see it in here anymore. So we're going to do graphs bar because a bar graph is good when you're comparing means. So let's do bar, right? And we're going to be doing separate variables. And that means we're probably going to look at cluster here. So cluster and separate variables. And bars represent, actually, we don't want cluster and separate variables. We're going to do something else. Let's do simple and separate variables. And we're going to put before and after into here. And on our options, we're going to hit display error bars, and that will be the confidence interval, 95. So you don't have to change this because we generally use a 95% confidence interval. Hit continue and hit OK. And this is what we got, before and after. Now, the way I set it up in the document, in the PDF document guide, is a little bit different. It's a ways of changing the error bars and looking at the graph a little bit differently. But this is fine. I mean, you compare these two, they're very close to each other. These error bars are overlapping. When the error bars overlap, it generally means that the two groups are not significantly different. Now, they are significantly different on a one-tailed test, but the error bars represent two tails. So the error bars represent two-tailed tests, and they overlap. So I would say they're not significantly different, and the data backs that up, 0.054. Two-tailed. So these error bars won't show you the one tail. There might be a way to change them, but off the top of my head, I don't know how I would use this to represent a one-tailed test, since error bars usually are two-tailed. But you can see it's very close. And the graph starts at 0. You probably don't want it to start at 0 because it makes this difference seem very small. And this is where playing with the graphs, people get angry and they say you shouldn't be changing graphs. Well, you can change the y-axis a little bit here. Let's start the y-axis not at 0. Let's start it way up here. Let's start at 1,000. So change the minimum here to 1,000. Maximum at 1250 is fine, and increment at 50. That looks like it'll be okay. And look at it now. Well, that kind of looks ridiculous. Look how big these error bars are. So I'm gonna have to make this 50. Let's make it 100. Let's see what it looks like. Still big. Yeah. And this is like changing the graph so it looks better. And I've actually made the graph look worse. So there's no science here. It's just basically how do you adjust the graph to make it look the best for you here. Let's see what it looks like with 1200. Okay, but these error bars are huge, so I'm gonna not bring this to 1,000. Let me bring it to 800. Do it that way. That looks better. It looks better that there's more room here. It's the same graph as before. I just changed the scale. I changed the y-axis and the tick bars to make them bigger, but it's the same as before. It just doesn't start at 0. So that looks a little. It looks like a bigger. At least it looks a little bit bigger than it does here. If I'm trying to show the difference, close this out. Where did I put it? Here it is. There's your graph, and then you can change the. This could be GRE score. I have to click on this. I'm not super interested in showing you graphs because there's a lot involved, and I don't know how I really feel about SPSS graphs. I mean, sometimes they're nice looking, and sometimes I'd rather make graphs in a different program. It can be annoying at times. So this is GRE scores. So I can do GRE scores like that. I can add a title if I want. That's sort of what it's going to look like that. And the error bars are two-tailed, and they overlap, which shows that the two-tailed probabilities is it's not significant. I don't even know where these bars start or end. I got to look at the data points here. I'm curious to see where the confidence interval is starting and ending here. This looks like a 117.33. It's not showing me the top here. Oh, that's the mean. I'm sorry. It's not showing me the error bars at all. There might be a way to show them, but it's not showing me the error bars here. It shows me the mean. If I click the bars, it shows me the means. I'm trying to get it to show me the error bars, and I can't get there. So I'm not expecting you to figure that out, obviously. Um, there's probably a way to. There's probably another way to do it. I'm not convinced where these error bars are, to be honest with you. I want to check that they're the right size because I've had some problems with SPSS and error bars, but none of this is really important for what we're doing, which is correlated groups t-test. So we did the correlated groups t-test. I did the graph. I want to show the graph again. It's graphs, bar, simple, separate variables, define, before and after up here, right? Options. I put the error bars in here. They don't really look great, but I put them in here to continue. I hit OK, and it makes you the graph like that. And that graph is fine. You can play with the scale like I did in the previous one. I played with the scale. It makes the error bars look bigger. I actually think it looks worse with these bigger error bars. This might even be better. It's not. It's not a convincing difference. Like if I was to talk about this at a conference, this is not a graph that I'd want to really spend time on because there's really not much difference here. I'm expecting after to be greater than before, but if you look at it, it's such a tiny difference. And it's only significant with a one-tailed test, which is, and some people will have a problem with that anyway. So that's how to do the graph. There's other ways to do the graph. I'm just showing you the fastest way to do the graph. Let's take a look at the other problem here for correlated groups t-test. It's looking at the grades.sav file, and we're looking at lower and upper class GPA and lower and upperclassmen. So this is lower and upperclassmen. Now these are two different groups. So this would be independent groups design. So I'd have to do independent groups T here. For the correlated groups one, it'd be quiz 1 and quiz 5. Is there a difference? Because it's the same people. Taking quiz 1 and quiz 5. So let's take a look at that. Let me get rid of this. Let's do quiz one and quiz five on the grades.safe file here. So analyze once again, compare means, paired samples T. Let's do reset that. Let's do quiz one and quiz five, although it looks like we had that at some point. And it looked to be at a one tail significant. If you look at it, quiz five is greater than quiz one, which is what we'd expect. We'd expect quiz five to be higher because you're used to taking quizzes. It's the fifth time you've done it, so you should be getting better at it, regardless of how much you know. You should be getting being begin you should be getting better at the format of the quiz. The quizzes are correlated 0.504. That's fine. They should be same person taking them. And if you look at the t value, it'd be t parentheses 104 equals negative 1.860. And if we're doing greater, one tailed, it'd be 0.033. So that would be a significant one tailed value. So it'd be t of 104 equals negative 0.1860. He is equal to one tailed 0.033. And we'd be rejecting the null. And we conclude that quiz five is greater than quiz one. If we're doing two-tailed tests, we're looking at just for differences between quiz five and quiz one, we would not be able to reject the null because the two-tailed probability is 0.066, and that is greater than the alpha value of 0.05. So this only works with a one-tailed critical value, one-tailed test directional hypothesis. And that's it for correlated groups T in SPSS. So hopefully that's straightforward. I know the graph is, probably a little bit meandering and not as straightforward as I would have liked, but there's a lot of different little things in the graph that can be fixed and can be tweaked. With the basic graph I did with the two columns next to each other, the first run, that's fine. And I'm not going to even really ask for a graph, so it's just showing you that you can do a bar graph in SPSS. And the bar graph is good for comparing the means of multiple conditions or multiple groups. So hopefully that makes sense. If you have any questions, let me know. If not, bye for now. See you next time for ANOVA.